Hi everyone, I'm Jasmine Lang, Assistant Director of Talent Networking at SGInnovate. A very warm welcome to all of you for joining us today. Thank you. This is our first community event in 2021. For those of you who are new to us, our mission is to help entrepreneurial scientists build and scale deep tech startups to solve the world's hard problems. We invest in deep tech startups at the early stages, venture build with them, and connect talent to opportunities with our portfolio as well as in the ecosystem. Special shout out to Jean, my community and brand colleague who has put together today's session on the next step for deep tech in Asia to all of you audience members. Today, I'm privileged to be able to introduce Peter Norvig, Director of Research at Google, at this session, who will share his views on deep tech innovations we can expect to see in the market moving forward. Peter previously directed Google's core search algorithms group. He is co-author of Artificial Intelligence, A Modern Approach, the leading textbook in the field, and co-teacher of an artificial intelligence class that signs up 160,000 students, helping to kick off the start of massive open online classes. Prior to his work at Google, Peter was NASA's chief computer scientist. He is a fellow of the AAAI, ACM, California Academy of Science, and American Academy of Arts and Sciences. Peter, I was one of the 160,000 students who took and completed Intro to AI, the online experiment you started with Sebastian Thrun when you were not content with status quo and wanted to push the boundaries of your sector. So having been based at Palo Alto at that time, I embarked on the course out of curiosity and ended up completing the take-home exam on a 17-hour plane ride so I could make the final submission timeline. I still recall you teaching the traveling salesman in Bucharest example under hidden Markov models. It was an incredible experience to have learned the basics of AI from the course, which has given me a great foundation for the work that I do now. So before we go into this session, I wanted to take the chance to share with particularly our local-based talent community the various initiatives SGInnovate has to groom deep tech talent within our shores. So let me do a short screen share on this. So we have 3 talent programs. The first is Summation, where we have identified deep tech companies to offer apprenticeship projects in fields such as AI, cybersecurity, and IoT. So Tiger, one of our panelists for today, is also on this program as well. The second program that we have, Infinity Series, this is an expansion of Summation, where we have looked into offering projects that are in software development, data analytics, and UI UX. So both of these are suited for people looking for their summer internships and are from undergrad to PhD levels. Do check them out. We are having a very short window of application timeline till 15th of January for them. And the third program is PowerX, where we have identified robotics companies to offer traineeships for those who have about 1 to 2 years of coding experience and would like to transit into the robotics field. So we have the first batch that is in progress right now. Finally, I invite you to check out our portfolio companies on Talent Marketplace, where you'll be able to read more about what all our companies do, as well as the offerings they have right now. So I'll hand the screen over to Peter for his sharing.
Thank you, Jasmine, for that introduction, and thank you for taking the class. Okay, let's see if we can get this sharing working properly. So I wanted to talk about some of the technology areas that I'm interested in. There's just so many. I think the intro that you guys put together touched on a lot of them, and it seems like we're interested in a lot of the same things. I'm going to focus really on machine learning applications because that's where I've been spending my time. And to me, I think one of the really exciting things is in robotics. It feels like we're at a period now with robots similar to where we were with personal computers in, say, the 1970s, where at that time, you could buy a kit and you could see the technology was really cool, but it wasn't quite practical yet. But yet within a decade, personal computers had taken over everywhere. So I'm not going to predict exactly when that's going to happen, but it's coming. One of the big applications of robotics that everybody's talking about is with automated cars. And again, that's been a little bit slower to roll out. And I think we as a field are learning a lot about how hard it is to interact with the real world. It's easy to do things that are completely online because you can control the environment. But once you get out in the real world, there's a lot of uncertainty. And as a field, we're learning a lot. I think in the next few years, you'll see not full automated driving everywhere, but you'll see specific applications like delivery vehicles or trucks working on a work site and so on. And you'll see automation coming to them first before they come to the general public. There's also great opportunity in sensors. Another thing that's holding back automated cars is the cost of the sensor package we have to put on them. But every year that's getting cheaper and cheaper. So these two fields will grow together. I think for the foreseeable future, one of the best applications is in warehouse robotics. I think you'll see a lot more use there before you see the robots in the home. So yes, you know, you can buy a robotic vacuum cleaner now, but its applications are limited, and it's tough to make progress there because everybody's home is different. Whereas in the warehouse, you know, a large company can kind of customize the robots just for what they need. The benefit is clear and obvious. So I think that will be taking over in the next few years, and then that technology will start to trickle down to the everyday consumer. A big part of what makes robotics possible is computer vision. And I think I was just looking over some statistics, and of all the machine learning projects we're doing at Google, and it touches almost every single one of our products, has machine learning in it in one place or another. Computer vision is the majority of those uses. So there's just so many applications that touch on computer vision, often combining it with other things. And here you see tagging objects in an image. We can do a good job of that. And now we're just looking for what are the right applications of this type of technology. And we're seeing new uses every day. Now, one of the issues that has come up is these so-called adversarial images, where we can get things wrong and the computer can't really explain why it got something wrong that seems so obvious to us humans. And one way to address that is with the understandability of our models. So we worked on something we call concept models, where an expert, you know, on the top we say, you know, a doctor knows something. He has these concepts of bone spurs and scoliosis and so on. So the doctor should be able to have a conversation with a computer vision model to say, these are the things I know. And when you're showing me things and you're making a prediction, make them in terms of the vocabulary that I already have. And the same thing, if you're an expert in identifying birds, you have some ideas, the important features are the wing color and the tail color and so on. You should be able to have that conversation with the model using the vocabulary that you as a person know, rather than the vocabulary that the computer comes up with on its own. So this idea of making, increasing reliability by having communication, I think is important. Whereas in the early days, we were just saying, you know, the only thing that matters is getting 99% correct. Now we want to get 99% or more correct, but we also want to have an understanding of why we got it correct and why maybe some of them are wrong. So this whole idea of better user interfaces for our models, I think will be really important in the coming years. Another important part of computer vision is in medical imaging, and in your intro, you mentioned some of those ideas. That's going to continue to be important. We've seen examples where computer models can do as good or better than trained doctors. We've also seen them do things that doctors can't even attempt to do, right? So in the bottom here, you see diagnosis of eye disease, and we were doing a good job of that. But then we could also start picking out other indicators of disease. Can you discover problems with diabetes or with heart disease just by looking at the eye? And the doctor says, no, that's ridiculous. You can't do that. But it turns out that these computer vision models can do those kinds of things. So there's a lot of excitement here in seeing how can we combine what the computers can do best with what the doctors can do best and come up with the best of both. There's been recent advance in protein folding. You know, some people are saying this problem is essentially solved. And And it's great to solve that problem on its own, but what it really means is that we can start designing new types of drugs and new types of therapies and so on. And we're just at the start of making that happen. And it's clear that's going to be really big in the coming years. Now, one of the things I'm most excited about is this idea of large multimodal models. So what do I mean by that? So large just means we have more data, we have more computing power, and the models we make are larger, they have more parameters to them. And everything we've seen says that you can do better as you make these things larger. And multimodal means we're not going to limit ourselves to just one type of data. We're going to combine image data, videos, language data, speech data, put them all together, and each one of those modes makes the other mode better. And so here there was a recent work coming out of OpenAI where it was trained on images and on text, and you could ask it to make up things. So here the question was, show me a picture of an avocado chair. And it came up with all these answers of what an avocado chair might look like. So there's creativity there, and a lot of that creativity comes from this multimodal aspect, where if you only had language or you only had images, you wouldn't be able to combine the two in this way. And we can be multi across languages, we can be multi across the modes, across different tasks. So these natural language models, there's many things you can do with them. You can have a conversation, you can translate from one language to another, you can answer questions, you can generate text and so on. And just a few years ago, we would try to solve each of those tasks with a separate solution, a separate program. And now we're saying we can train one model that can do all those things at once. And I think that's really exciting because it's getting closer to general intelligence. And here's an example of using one of these models to have a conversation, but the same model can do other tasks as well. And then the final thing I wanted to hit on was this idea about automated machine learning. So, I spend most of my time with a bunch of PhDs who have been doing this for a decade and have a lot of expertise in building machine learning languages, and we try to stay at the state of the art. But we also want this technology to trickle down to somebody who's just getting started, who doesn't have that experience, but says, I have some data, I have a problem, I understand machine learning can help. I don't want to have to, spend half a decade in grad school learning how to do it. Can you get me started right away? And we're starting to see these types of approaches where you just give me your data, you tell me what you want to get, and the system comes up with a machine learning language model on its own. And so I think that's going to be exciting to really allow this technology to be democratized and get in the hands of everybody rather than in the hands of a small number of experts. So why don't I stop here and we can open it up for panel discussion and for you in the audience.
Thank you, Peter. Appreciate that glimpse into all your focus areas. Robotics is a pet area of interest. I'd love to pick up that discussion with you at a later time as well, and for discussing the priorities in deep tech. So good morning to everyone. Warm welcome to SGInnovate's very first deep tech panel discussion of this year, titled The Next Step for Deep Tech in Asia. My name is Suchitra Narayan, Suchi for short, if that's easier for those of you that don't know me. I'm a director with SGInnovate's venture building arm. I've spent a large part of my career providing management consulting, commercial advisory, product management, corporate partnerships, particularly in Australia and Asia. So I'm really, really excited to be a moderator for this session for the next step of deep tech in Asia. going to start, I think, Jan 2021 for me has been deeply philosophical in terms of reflection. So I'll start with Greek philosopher Plato, who said necessity is the mother of all invention, right? And 2020 has been an amazing testament to that. It was sort of a year of crisis, and at the same time, it provided the perfect timing for deep tech to shine. And we saw a lot of deep techs in Singapore and also around the world coming together to develop solutions, to help the environment, to help the people rather swiftly contain the global pandemic, protect lives, sustain work, and so on. And we've also seen massive waves accelerating towards digital transformation in 2020. Partially because it was planned, but partially because it was accelerated by the necessity created in the pandemic. The manufacturing sector, for example, was really quick to review automation, digitalization, and implement quick changes that enabled them to meet the customer needs during the pandemic. Commercialization of deep tech was accelerated in 2020 for some sectors. Admittedly, there were pockets of deep tech for which saw that happening as well. And as the pandemic is settling down into the new normal, we're joined today by two incredible panelists to discuss the next steps for deep tech. Peter, all of you are familiar with. He's a director of research with Google. And our second panelist is Sinue Arroyo, the founder and CEO of Tiger. So since we've met Peter through his presentation, may I invite Sinue to give us a quick introduction of himself and his startup solution in deep tech as well.
Thank you, Suchi. Thank you very much, and great honor to share this panel with Peter. I have his book by my bed. This is the Bible for me. Great honor. Thank you so much. So yeah, my name is Sinue Arroyo. I'm the founder and CEO of Tiger. Tiger is a local Singaporean company, deep tech, specialized in automation. We are marketing an automation platform that combines search, chatbots, recommendation engines, and document reading. And we have a presence in 5 countries now. We are around 140 people and rapidly growing and expanding. We are deep tech. I mean, I hold a PhD in artificial intelligence, not specifically in machine learning. I come from the knowledge representation, automatic reasoning, what was called semantic web. I also hold an MBA from the University of Chicago, Booth School of Business. And the most salient innovation that we have is this tool. It's called Cognitive Studio. I mean, innovation research, right? We've been pushing the boundaries of technology that allows any non-AI expert to build a document reading model literally in minutes, whereas before it took us months and hundreds of thousands of dollars and people. Now you, Suchi, could just use this tool to read a document reading model for any structured, semi-structured document and get accuracies out of the box in 5 minutes, around 80–90%. So really groundbreaking technology. We're very proud. Something we built in Singapore and that we are commercializing through all the places we have a presence.
Thank you for that, Sinue. Very exciting product, and for people in the audience who are interested to reach out to Sinue, do that. I'm sure he'd be happy to have a discussion with you, and we'll learn more about it during the panel discussion as well. Sinue, while I have you in the spotlight, can you share with us what the journey has been like commercializing your solutions in 2020? Sort of what shifts have you seen in the market, and what really was particularly challenging about 2020 for your organization?
Yeah, very good question, Suchi. Thank you. 2020 was a very challenging year. We basically had only half of the year to do our sales and commercialization. The world shut down in the second quarter. The third quarter, we started to see things coming back online, but drips and drops quite slowly. And now we're seeing the fourth Q was really strong. And we're seeing 2021 an energy to try to catch up for all that was not really done on the previous year. At the beginning, we saw uncertainty. People didn't know what was going to happen. They were trying to find their way. It was very uncertain, right? So we continue buying, so we continue deploying. In many cases, we have on-premise operations. So we have to go to the customer to deploy. and we could not do it, right? In other cases, negotiating through Zoom created a barrier for purchase orders and etc. because people is afraid that they are going to be recorded and that you are going to use that for some reason. It's true.
Right.
So that put a stop to everything. So only when we could start slowly meeting people again, then we could start seeing, the process coming back online. Now, what we've seen, and especially in our case, because we are an automation company, automation before was, okay, we have to automate. Now, it's not any longer the case. You have to have automation because this is part of the business continuity plan. If your people cannot go to work, you have to have an alternative for your business to continue operating. So we've moved from, yes, we want to automate, we want to reduce costs, the usual speeds, we want to be more efficient, to we must automate. This is a strategic objective to our business. And this is what we're seeing in 2021. So 2021 is starting a really strong footing for us. We are going back to our doubling of revenue that we were doing in the previous years. So that's really exciting, and we see a very, very promising market ahead of us.
Oh, that's fantastic news, and good luck on that. Peter, I mean, Sinway brought up a really, really interesting point, because even though he was mentioning that sales on Zoom, it's a challenge, commercializing these technologies at the time of pandemic. It's such a challenge, and for startups, it can be a make and break opportunity. So how do we better harvest these ideas? The journey is tough. We're noting this from Tiger, but what can we do in relation to some of these areas, particularly that you've highlighted that Google also thinks should be commercialized, but the reality is startups are struggling on the ground to commercialize them?
Yeah, I guess one of the things I've always believed long before the epidemic was it's easier to do sales if you're asking for less. And I remember being at a company where, we made an enterprise level product and you could sign up for $50,000, and it was really slow going, getting a sale. And then we decided to switch strategy and say, you can sign up, there's a one-page contract, there's no money down at the start, but if you start making some money, then there's a revenue share approach. And that was the turning point for that company. I think, now I'm at Google, and we have a similar type of thing where we don't ask you for a big commitment up front, but, you could start showing ads and spend $1 a day. And then if that works well, you can increase from there. So I think allowing people to get in and try things out easily, I think is good, both because it's a shorter sales cycle, and it also means you have more people you can connect with. If you're selling a big product, you can only go to the VP level and up. Whereas if you're selling a small product, you can go hit anybody within the company who, happens to read an article or see you on LinkedIn or whatever. They can get interested, and then they can start to engage, and then you can build from there. So that's always been my strategy, and maybe that's just the way I'm built. Is that's the kind of thing I like, because you can sort of concentrate on the technology and getting it right, and not have to worry so much about the sales ends of things. So that's what I would encourage customers to focus on. And
Peter, that's really interesting, because I used to work with the corporate executive board, and it sort of goes back to the fundamentals of sales strategy. If you deliver to the customer what the customer wants and allow the customer to grow, once you show growth, then nobody's going to say no to paying and sharing a part of that growth story with you. Now, I appreciate that sentiment. It's the basics, old school way of thinking, but it's the foundation to good sales strategy. Nothing's changed from there. Sinway, Tiger is actually headquartered in Singapore, right? So really curious to understand, how are you thinking through 2021? What's driving your tech roadmap? What are you seeing in terms of deep tech developments? Because you mentioned already your quarter is looking good, but in terms of the surrounding industry, and what do you see as a deep tech coming out of Asia? And Peter, I'm curious to hear your response to this as well, to see what's coming out of the United States and see if we can map the two questions together, the two responses together.
So I think in the field of software, computer science, there is a few but very interesting salient companies. I mean, we have Vicens, for example, doing great things in visual search, Tiger taking its position in automation, and there are a couple others that are doing great things. So we see more research happening in this part of the world. We have a research center, a small lab in Spain, and we participate in these European research programs and bring Tiger in Singapore to cooperate in those programs, the Eureka program, et cetera, et cetera. So I think there are very many opportunities for cooperation and many good things happening. Now, if you focus on smart manufacturing or biotech or even food innovation, I think Asia and Singapore are investing a lot of money in those areas. There are very interesting companies out there as well. And I see a lot of very interesting things. You have things like Bioformis, recently invested by SoftBank, where you guys, I think you are also part of that, right? It's a great success story and a great research and innovation case study. So I think, I mean, we don't have the capillarity, obviously, that the US in terms of amount of companies, but I think there are a few very interesting pearls on the ground that are growing and growing and growing, and I think they are going to change the world for the better in the very short future.
Okay, and so of course I'm sitting in the heart of Silicon Valley, and so that's a great place to be if you're in the tech industry. And there's a lot of advantages of being here. There's disadvantages too, right? So it's expensive, there's competition for hiring and so on. And I've been spending a lot of time with Google for Startups, and we have programs around the world, in Asia, in Africa, in the Middle East, in South America, and so on. And we see a lot of companies there doing things that would be hard to do coming out of Silicon Valley, just in terms of understanding what the local marketplace is like and being able to reach them and sort of put together the product that makes sense, that maybe somebody else wouldn't understand and wouldn't be interested in reaching. So I think you can be successful from anywhere if you have the right drive and the right idea and the ability to execute on it.
Thank you for that. Peter, I want to go back while I have you on the screen. I want to go back to your presentation where you sort of identified, you started with robotics. And like I mentioned, it's a pet passion of mine. I'm actually working on a project where we're bringing together hardware, software, connectivity, data analytics. It is that whole multimodal model that you referenced earlier. And the solution is adapting robots and end effectors with a sense of human touch, combining high-speed sensors and AIs. So what are some of the new technologies that you see in robotics? How do you think these applications will play out in this space as we come out of the pandemic? Do you see an increase? Do you see that expense is going to be more important? What do you see as the short-term future?
Yeah, so certainly there'd be a lot of medical type applications which have some robotics components and other components as well. People are looking more at delivery type applications, right? So you used to feel fine about going to a restaurant or going to a store, and now you're less willing to do that. You'd like to have less human contact, and so putting a robot in that loop seems like an attractive thing. And it's too bad we don't quite have the robots quite ready to do that, but we will soon. And that will change things. And even when you don't need to social distance from people, that will still have an impact on the way business is done, the way products are delivered. So I think that's really interesting. And that, we're seeing a variety of things, from the self-driving cars to smaller sort of cart-sized robots to flying drones and so on. So there's a lot of possibilities there. And to me, maybe like you, I'm just really interested in robotics from a kind of scientific or theoretical point of view, just because of the nature of the problem, right? So, I spent so much of my career as a computer scientist saying, well, the way we solve problems is by making them digital and making all the uncertainty go away. And now we can put this problem online and we can solve it within that restricted kind of digital or binary domain where everything is true or false. But you just can't do that with robots. And they're always going to be dealing with the real world and dealing with uncertainty. And so if we can do that, then that just opens up all these technologies for doing everything else. And now we can start attacking all the hard problems of uncertainty. And I think a lot of that will come from learnings that we have in robotics with reinforcement learning and so on, right? So we focused so much in the last decade on supervised learning, where you have examples of, for this input, here's the right output. In robotics, we don't really have that. In robotics, we just go out and explore. So I didn't really comment on it, but the first slide I showed was a collection of robot arms who were just playing. And, so we have a program where we go out to garage sales and junk sales and just buy every little thing we can. And we dump them all into a bucket. And then the robot reaches in and says, I'm going to learn how to grasp this thing. Mm-hmm. And, this one's a little bit funny, has a funny shape, and it's different from anything I've ever seen before, but I'll figure out how to hold on to it. And these things are just running 24 hours a day, playing and figuring out what the real world is like and what the set of all possible objects is like. So I think that's really interesting, the way they can explore on their own rather than be programmed what to do. I think another really exciting part of that is the sim to real conversion, right? So you can only do so much in the real world. We can only run these things at real-time speed. But in simulation, we can go much faster. But the problem is the simulation has to have some connection to the real world. And as we learn more, the simulations get better and better. And so there's this kind of exponential speed up that once we get past the point where the simulations are good, we can learn so much faster. And it feels like we're getting close to that happening. And I think that'll be a time when we'll see robotics accelerate really quickly.
Yeah, we in Asia, I think, because labor is relatively cheaper than the Western world, making a business case for robotics is always hard. But we are seeing that starting to change now, particularly with the pandemic, because of safe distancing. When you look at supply chain logistics, there is a requirement now of safe distancing, which means your lines slow down anyway. And so the robot, to your point, of the speed of the robot versus simulations, that speed is sort of good enough for the moment versus shutting down the factory floor altogether. So I certainly look forward to seeing what you said, and increasing speeds to automate and live with robots as coexistence rather than them taking over tasks and jobs 100%, which was sort of humankind's expectation pre-pandemic. And on that topic of change and what we're seeing in 2020, and it has been significant. I know I keep going back to it, but it has been significant. So Sinue, here I'm curious to understand, that shift that we are seeing from a robotics perspective, it's pretty dramatic, going through a mindset change and overhaul of systems, processes, staff training. It is daunting to accept change and acknowledge that the time has come where you can't live without automation, where you do need certain solutions. How have you or your organization helped your customers overcome this inertia? So I'm going back to the root of commercialization. How do you encourage these businesses to go through that rite of passage for digital solutions post-pandemic?
So one very obvious aspect is what you pointed out before with the cost of labor, et cetera, et cetera. So you automate, so your cost of operation gets lower, and your operation becomes more reliable over time. But that is just only one part of the equation. The other tool that we actually use is the free the intellect of your people. We are doing many things every day that don't really contribute to our intellectual development, or are things that we just need to do, right? Fill that expenses form, or do that, it's stuff that we need to do. So one aspect that we put on the table is like, you have all this stuff. They are doing a lot of things that are not very interesting for them or for you. Why don't you automate that away from them? Give them more time to focus on the really value creating aspect of their job, or even promote them to do something else. So it's kind of, this is a phrase that we run at Tiger, is free the human intellect. It's a slogan, but it's very true. It's not just about the dollar amount. It's not just about the resilience of the operation. This is great, but what is it for the person? How is automation going to be my life better as an employee of this company? Am I going to have better opportunities for training, for self-development, for career improvement, for career progression? Yes, automation can afford all those things. So that's another aspect that we put to play.
Thank you, Sunway. In the interest of time, I'm just keeping an eye on the clock. There are a couple of questions that have come up. To the panelists, I'm just going to switch over a little bit, ensure that we get a couple of our Q&A questions answered, and then I'll come back to a couple of questions that I do have for you, and then we'll wrap up the session. So let me move to the first question here. What are the significant gaps that we are facing in attaining artificial general intelligence? Is it a matter of designing effective learning machine learning models and algorithms that rely on less on high volume data of training, or will neuromorphic hardware architecture enable that?
I guess from my point of view, I think what we're missing is the right level of generalization. And people talk about this as transfer learning, as getting away from supervised learning, right? So we don't want to say that every problem we're going to answer, you have to go out and collect 1 billion examples before you can get started, right? We want to be able to get started right away. And I mentioned that a little bit in my presentation, where I said I was really excited about these multimodal models. And there the idea is you train up the model ahead of time. So rather than, sort of the traditional approach is, I want to do a machine learning solution, so I'll collect some data, build a model, and then serve it. Instead, you say, I've already collected a lot of data. Now I'll sort of take a subset of the model that I got from that and see how it applies to this problem, and maybe add in some new data specific to this problem. But most of the solutions should come from things that I already know, rather than things that I have to learn anew from scratch. And we aren't quite at the stage yet where that's an easy thing to do, where data from one problem transfers over to another. But I think that's the biggest problem that we're facing, that we have to solve in order to get to more general AI.
Sunway, did you have a comment on that, or shall I move to the next question?
No, please move on.
Okay. So Peter, this question is for you as well. It is about robotics, and the reference being that there are longer timescales for prototyping and time to market. What are your thoughts on funding mechanisms that startups should look for? Because the timescale of VCs could be misaligned, especially since there are not many precedents to look up to.
Yeah, I think that's right, that if you compare a robotics problem to a sort of traditional software problem, it will be a longer time scale in most cases. But that's not really unique, right? So there's lots of businesses that are like that. Sort of any business that's creating a physical object for sale has to go through that stage. So you shouldn't feel like you're being singled out and you're the only one facing this issue. And how do other companies do it? Well, they build prototypes, right? So, you want to be a car company, and you build something to show that's not quite finished yet, but shows you're on the right track. Or you build a component rather than build a finished product. And you find a customer for some of your components, and you build up a revenue stream while you have a vision towards the final solution. So I think that the assumption of the question is right, that you have to think more like a hardware company than a software company if you're involved in robotics, and follow the strategies that they use.
Another interesting one, and I think I'd love to hear from both of you on this. What are the key skills to acquire for a human to survive and compete in this era where robots achieve human level of intelligence? And so in a way, this also applies to software, I think, from a perspective of replacing human beings. And hence, what is your advice for human survival and the key skills? This is an uber question.
I think you have to keep curious and continue learning. I mean, you cannot just be stuck and this is what I do, this is what I know, this is going to be my 50 or 40-year career. No, you have to, we are living in a very dynamic environment. We are talking about jobs now that didn't exist 15 years ago. We are creating jobs now for the future, and some others that were created very recently will disappear. So you have to keep this open mind, willingness to continue progressing and learning. Singapore is doing a great job in this with this continuous learning, skills future, all this stuff. So it's not a one thing. I go to university, this is the skill I learned. That's me, I'm an engineer. Look at me, I started being a scientist, move out business, doing sales, and and I continue learning. I'm doing stuff. So this is what I'm doing now. Maybe in 15 years, I'm doing something else. I'm progressing in that path. So I think that's the key for me.
So I agree with everything Sinu just said, and I think one more thing to add is that what you can do best is to be a person. And robots are not as good at being a person, and it's not just checking the box that says I'm not a robot. It's more than that. And I remember I read a science fiction book that was about aliens come to Earth and they have amazing technology, and all of a sudden everybody's out of a job because the alien technology is so much better. And I said, well, that's not really realistic, because the aliens are going to need human factors, because the aliens are not humans, and they're not going to know they have the amazing technology and they can make the flying car and so on, but they won't know how to make the door handle just right for a human to be able to open it. So there'll always be jobs for people that understand what it's like to be a human, and the robots can have the other jobs.
And if I were to just add to that, extrapolating to commercialization of technology, that's such an interesting comment, because as we are here on Earth, no alien invasions with the startups, often it's not the best technologies that win. It is about understanding how do you integrate well enough with the people who are consuming that technology. And sometimes you don't have to be 100% perfection in terms of technology. It's giving that 80% of the solution that the customer actually wants to open that door that would help that case as well. Another question for you, Peter. How do you see the use cases for companion robots for kids and seniors?
Yeah, I think that's really interesting. I'm not an expert on that, but I guess that ties into this idea of being a human or having empathy. And I'm not sure how much this is a technology question. I mean, I remember my daughter having a robotic companion that was very successful for her, but didn't have much technology in it. It was a teddy bear, right? So I think, we humans are willing to meet the technology more than halfway. And, if it can just do part of the job, we're willing to do the rest. So again, I think this is kind of a human factors question of how do you build something that people will like and want to engage with, and I think that's great if you can build the right thing.
What are some of Google's plans to work with our Asian deep tech startups, if any, to unlock partnership opportunities?
Yeah, I don't know all the plans. I've been working some with the Google for Startups, and so we have a program that companies can come in and get some training and talk to us and get some ideas. We also have programs to teach companies how to use the various technologies we have. So I think there's a lot of opportunities.
Sounds good. So folks in the audience, if you ask that question, you know who to reach out to, and I'm sure you'll figure out the contacts in Asia as well. Let me, again, I'm keeping an eye on the clock, so I'm going back to one of my questions that I really want to hear Peter and Sinue's responses to. Are your personal tech predictions and wishes for deep tech in 2021? Would love to hear that, and audience, I promise we'll get back to your questions after
that. Okay, I'll take that. I guess one of the things that has really struck in me over the past year or so, and will continue into 2021, is trying to figure out what it is we really want our technologies to be doing. And, you know, I used to think that what we had was a technology question of, you know, can I optimize this software to the nth degree? And now I realize, well, we've got a lot of great optimization techniques, but what we really need is to understand what is it that we're building, and are we making the right thing? And so all these issues around fairness, and then tying into other issues of privacy and so on, these are becoming much more important. So it's not just what's your score on the metric and did you get the best score, but it's all these other issues and how they combine together, and how we can build a system that people will trust, feel like it's working for them rather than just working for the company that made it, and feel like it's helpful in their life. I think these are the big questions, and these are different than the technology questions. These are more sort of sociology questions. And so that's been a big change in my focus over the past year, and I think it will continue in the coming years.
And any tech focus areas that are your predictions for 2021?
Well, I guess I started to do that at the start. So robotics, computer vision, natural language understanding. I think we might be close to an even bigger breakthrough in natural language. You know, it's more like 2015 or so was when we kind of cracked computer vision and got a big jump in the capabilities there. Feels like we're right about at that stage for language as well, right? We can already do spelling correction and maybe machine translation. And we're starting to get to the point where conversation really works. I mean, right now you can talk to your devices and you can say, tell me the time, or tell me the weather, and maybe a dozen other things. But then you start to run out of things that you know are going to work when you have a conversation with your device. And I think it'll really be transformative if we can get to the point where you feel like no matter what I ask my device, it's going to come through and it's going to have a good answer and it's going to be as good as a human assistant. We're not there yet, but we could get there in the next few years.
Sinue, can we hear your thoughts on the same?
Well, I could not agree more with Peter. I think we've made tremendous progress in image processing and language. This is an area where Tiger is working deeply, is there, and we'll crack that problem. We've cracked a portion already, but we'll crack it in full in the next years. I like to see it, but I think it's an early stage. I love to see more progress in quantum computing. I think that is going to change the scale of the game and how we solve problems, how we tackle problems. But that is probably, I don't know, 3, 5, 6, 10 years away. But definitely an area where a lot of progress should be done in 2021. Other than that, I think areas like smart manufacturing and biotech is something that the pandemic has made relevant and very important to us. So I think a lot of cash is going to go into biotech, and that field is going to really explode in the next years probably. Food, as I mentioned before, I think is very important, especially for a place like Singapore, where we want to be food independent up to some extent. We take the example of the Netherlands that are great exporters of food with very small surface. So how we innovate, how we research, how we create value in those areas, I think is going to be what is going to be sounding a lot in 2021 and coming years.
I'm not hearing you now. Are you on mute?
Sorry. Thank you. Thank you, Peter. This is the most common phrase of 2020. I think you're on mute. There was, I said, interesting that in a way you mentioned quantum, because there was a question from the audience on quantum about how important do the two of you think quantum will be in 2021? And is it all of quantum computing, or is it very specific applications like quantum sensors? Do you have thoughts on that you wanted to share?
Yeah, I guess I agree that it's probably going to be 5 years or so before we have to worry about that too much. I mean, like 5 years ago, I decided, oh, I don't have to follow quantum because I'm going to be dead before it takes off. Now I'm reassessing that, and it's going faster than I thought. But certainly for the next couple of years, it'll be more around this signaling and sensing, and the quantum computing per se probably won't have a big impact until into the next decade. And then I think it'll depend. When I think about it, most of the things I want to do are not the types of things that I think of a quantum computer as solving, right? So I want to do things like, say, give me 1 billion web pages and I want to shove them through memory and do a tiny bit of processing on each one. And the quantum computer is not going to help you with that. It's something that says, I want to do a lot of computing on a small amount of data. So, other people will have different answers depending on what they're trying to do.
The next question was on AI chips. What are the challenges in the AI chip industry, or any thought processes around AI chips?
Yeah, I guess I'm not sure I like the term AI chip, right? So I think, we've had this idea of graphics processing units, and that kind of made sense. And then we found out they weren't just for graphics, they're good for other things as well. So maybe we didn't have quite the right terminology, and, calling it a GPU was too limiting. And I think calling it an AI chip is also too limiting. But I think we do want to explore this space of being able to do parallel computations and do them quickly. And then particularly the power consumption and the battery usage seems to be really important. And that changes the kinds of things you can do, right? So we've really, we've had a revolution in AI in the last few years, and a big part of that has been the data, a big part has been the algorithms, but we couldn't have done it at all without the increase in computing power. And so if we continue to do that, we can do more. And if we get these specialized chips that run at low power, then we can do more of that computing at the edge. And that's certainly something we're looking at. One of the things we've realized in the last few years, we always knew data was an asset, but now we've come to realize that data can also be a liability, and that sometimes you don't want to hold data because of privacy concerns and of the cost if you were not a good steward of that data. So sometimes we would prefer to say to our users, you know what, you hold on to your data, don't even show it to us. Run things on your device, and we have these ideas like federated learning that allow that to happen, and that all relies on having significant processing power on the local devices.
Thank you. There's another Uber question. It says, it seems like there's little overlap on the definition of intelligence across the board. How is it measured to have a meaningful discussion on where machine intelligence stands in comparison with humans? What is your definition of intelligence on a fundamental level? I'd love to hear from both of you on your thoughts on that.
Yeah, right. And so it's tricky, and these words are used in many different ways. And I always think of it in a 2x2 breakdown. So one, you can measure intelligence or understanding, or whatever you want to call it, in terms of looking at the thought processes. Are my thought processes valid? If I'm saying if A, then B, do they follow properly? or you can just look at the results and say, you know, I don't care what you were doing internally. If you get the right answer to every question on the test, then you must be intelligent. And AI traditionally has taken both of those approaches. Different people like one versus the other. And then in terms of what you're evaluating, are we evaluating it? Are you like a human in the way you operate, or are you ideal? Are you achieving the best possible result? And again, people have looked at both of those. So I guess I'm kind of more mathematical, and I would like to say, let's just measure your results on a test, and whoever does best is the most intelligent, if it's the task that requires intelligence. I think, you know, going back to the Turing test, some people look at that as saying, well, what Alan Turing was saying was you had to be able to be just like a human to imitate a human. But I don't think that was his main point. I think his main point was to say, let's not let the philosophers say it's impossible for a machine to think. Rather, let's say, let's define thinking as being successful on some task. And I think the important part was that there was a task, and not that the task was imitating a human. I think he would have been just as happy to say, you know, well, we've got other tasks we can measure now, and how well you do on that should be the measure of intelligence.
I could not agree, obviously, more with Peter. If anything, I'll give another spin to it. We are taking, for example, the ability of software to play chess or to play AlphaGo as a extrapolation of intelligence. Software and artificial intelligence works very well when we reduce the application domain to something that the software can reach. And those are examples exactly of that. As a human, I'm only not able to play chess. I'm only also able to drive a car, to have a conversation, to talk about philosophy, or whatever interests me. So I think it's, in a sense, a good marketing strategy, but wrong to extrapolate. I have a software that plays chess to I have an intelligent software. I think there are two different things. So I think intelligence, we can say software is intelligent when it kind of does the thing that a human is able to do. So not just a simple task, or however complicated that might be, but just one. You can, you know, put a number of those. And this can be, even now, relatively easily achieved when you start building from the ground up, right? So you're talking about games. So, okay, so I have a program that plays chess, that plays Monopoly, okay, so I go to the higher level, and that resembles some level of intelligence. But it's still, the creativity, the ingenuity of a human to tackle and solve a problem, I think that is when we will be there, when we are able to reach that level. And I'm with Peter, we are not there. So you might look at it from different perspectives, and yeah.
Thank you both. I think we can, we would all, I speak for the audience here, we would love to spend the rest of the day speaking with you, Sinwe, and Peter, the rest of the night for you, speaking with you. But as we draw this session to a close, I also wanted to share three of what I think are predictions in tech. I usually do this at the end of 2020, but you know, was a depressing time. So Jan 2021, I think we'll see an increased use of and adoption of automation. So watch for adoption in robotics, automation solutions. I think they'll become mainstream. If you don't, you know, capitalize on those opportunities, we'll see companies falling behind the curve and losing out on the market opportunities. The second one being, I think, digital transformation. It's no longer a luxury. It's no longer optional in the post-COVID world of remote work. And the third one is virtual collaboration systems. You know, I'm hoping that we'll see new systems and tools and solutions coming in. So hopefully, fingers crossed, next generation of Zooms, Teams, meetings, whatever else. Because one thing I realized that was really hard, and this is a very personal perspective, is the casual conversations, you know, the ones that you have at the pantry when you pick up your coffee or you go to lunch with your colleagues and you just exchange across business units, ideas, information, and so on. That is very limited with remote work. So those of you from the Zoom teams, if you're listening out, help us solve that issue. And finally, in closing, want to say a big thank you to our panelists for being amazing sports to answer all our other questions coming up in Q&A, spending your valuable evening and morning with us. Peter, such an honor to meet you virtually, and we look forward to meeting you sometime in person as well. Do connect with our panelists on LinkedIn or reach out to us through the SGInnovate page. We'd love to hear from you as the audience, and to all the wonderful audience, hope you have a great afternoon, and stay safe, everyone. It's still pretty bad out there, so stay safe. Thank you very much, and I'll call the meeting to a close.
Thank you.
Thank you, Susie.